meeting.
So Roland, if any questions you have, you can type in the chat. So DFS advantages we have seen. Number one, high volumes of data storage, basic DFS behavior. And second thing is it is supporting parallel process. Same DFS behavior for Hadoop kind of systems, that is called HDFS, Hadoop distributed file system. Within this Hadoop distributed file system, unlimited data storage feature is available. But I have a question here, because why I'm talking about HDFS is data lake concept same as HDFS. Got it? You take Oracle server, DB2, SQL server, even MySQL. Everything nowadays they are using clusters. In their clusters, they are using clusters. Hadoop Teradata also cluster. But in Oracle, why you cannot? Oracle is a cluster. Oracle server means in training centers only Oracle server is single CPU, sir. Not in our production servers. Understand? In production place of the Oracle is a cluster, not a single CPU. SQL server is not a single CPU, it's a cluster. A cluster is acting as a server. But my question in Oracle and SQL, why you cannot keep unlimited data storage? Because they have their own limitation. Suppose I am talking about some RDBMS databases, and there everything is a cluster. What is the max number of nodes I am talking? I am going to talk about only popular databases. You take RDBMS. In RDBMS, we can keep maximum 256 nodes only. You take a not RDBMS, in Oracle RDBMS. I'm talking about Oracle database. Suppose initially you have 5 nodes. 5 nodes got space got filled. You can add 6th node, 7th node, 8th node. Up to maximum how much? 256 is the limit for the Oracle. Take SQL server. Previously it was 108 nodes only. From SQL server 2000 onwards. Okay, not 2000, 2010 onwards. SQL server is also supporting 256. MySQL, only 54 nodes. In this way, take any RDBMS. There is a limit. Because of this limit, can you say unlimited data? One fine day, the limit has to be completed or not. Once 256 nodes got filled, you cannot add one more node. So that is the reason unlimited data you cannot keep into those databases. But these databases, you are not expecting that much of volume. These databases are used only for the OLTP, whatever the list you have seen. But if it is data warehouse, there are specialized databases for the data warehouse, like Teradata. Here, 1024 nodes only you can keep. When compared with Oracle, 4 times greater capacity, but still limit is there or not. Let's talk about Netizer. Here also, the limit was 1024. And Vertica, only 512. So is it possible unlimited data storage here? Not possible. But you talk about Hadoop. In Hadoop, what is our file system? HDFS. In case of Hadoop, you can keep, there is no limit for max number of nodes. That is max number of your worker nodes. There is no limit. So currently I have 4,000 nodes because I have petabyte of data. I have 4,000 nodes. Today or tomorrow, the 4,000 nodes space got filled. No worries. Tomorrow I will add another 500 nodes into my same data center for my Hadoop cluster. Again filled by next day. That means next day means by next year. I will add other 500 or 4,000 nodes into the same cluster. Got it? So in this way, there is no limit for max number of nodes. That's why indirectly unlimited data storage is possible. But for the processing, that is a distributed file system, parallel process is possible. Even though big volumes of data, because of parallel process, I can achieve the results in faster way. Understood this one? Same behavior of HDFS that is there in data lake. But I have a question. If HDFS existed, why data lakes? I can use HDFS, right? Why I need data lake? Simply, HDFS is a Hadoop distributed file system in on-premise. On-premise means you need to maintain your own clusters, that means own infrastructure. Sir, you have data of 1 petabyte, sir. 1 petabyte of data you want to store and 1 petabyte of data regularly you want to process. Not only storing your responsibility. You are storing 1 petabyte. Monthly average, you are getting 1 petabyte. And regularly, you are going to apply batch processes or analytics processes on that data. How much cluster is required? Minimum to minimum 4,000 node cluster you need. 4,000 node cluster means how much data, biggest data center you need to maintain. Understood the point, sir? How much biggest data center you need to maintain for that? How much infrastructure is required? Again, how one node and another node is connected using networking components. How many racks are required? How many switches are required? Not our electric switches, network. I'm talking about network switches. How many firewalls are required? Understood the point, sir? Meanwhile, some nodes will be failing. Immediately, replacement of nodes are required. Always 24/7 power supply is required. Very high bandwidth of internet is required. Is it possible to maintain that much of data center for a normal organizations, which are non-technical organizations? Is very tough. Okay, I decided petabyte, I decided to go for 4,000 nodes, okay. But unfortunately, next month, data highly increased. My data volume became 1 petabyte to 5 petabyte. But my existing data center supports up to only 1 petabyte. But next month, the expectation, I'm going to get 5 petabyte of data, 5 petabyte of data. Then I need to scale up my data center to maybe 10,000 nodes or 20,000 nodes. How much investment is required for me? Is very tough. Of course, Hadoop is open source, but maintaining infra is not open source. A lot of investment, a lot of hardware team, a lot of networking team, security team, a lot many other bloody stuffs are there. I don't want to take risk of all those things. I just want all these services in the cloud. Same distributed file system with unlimited data storage I need in the cloud. That is your data lake. It's based on this, a simple question for you. HDFS is DFS, distributed file system. Data lake is distributed file system. What is the difference between them? One is on-premise database, on-premise file system. This is on-premise distributed file system. This is cloud distributed file system. That means you need not to maintain any infra. The infra headache is by Microsoft. Infra headache is by AWS. That headache is by cloud provider, not by you. Simply how much data that you have, simply store that and process that. Got it? That is what the data lake is. Same data lake in our Azure cloud platform, that is called Azure Data Lake. Understood? So now come back to your picture. Here in the place of my warehouse, I'm keeping Azure Data Lake. What is the first fundamental benefit I am getting here? If I go with this, unlimited. No need to worry, my data volume is restricted to 200 TB or 300 TB or 1 petabyte or 2 petabyte like that. Today I have only 1 petabyte, but by next year, my organization may grow up to 10 petabyte of data. By 2025, it may reach exabyte of data. No need to worry. All data that I can keep into data lake. So that means the data lake is offering me some benefits here. Not only Azure Data Lake, sir. Every cloud data lake should provide this facility. Otherwise, you should not use that word called data lake. The data lake is offering you the benefits. The first benefit, number one, unlimited data storage. The second benefit of the data lake, it should support all varieties of data. That means all varieties of data. What are the different varieties of data? Structured data, unstructured data, and semi-structured data. What are the examples of structured data, sir? Examples, please. In RDBMS, where you are storing data? In tables, right? Table is a rows and columns format. The table is structured. Even you are keeping your data into delimited texts like CSV, comma separated value or tab separated value. Such kind of files, structured. Even in Excel, Microsoft Excel files, structured. In this way, many files are structured, many data is structured. But problem is, sir, today you are attending demo. Tomorrow you are paying fee. You are paying fee means one transaction happened. The transaction has to be recorded in the database. That is a structure. But I am taking class now. My class is being recorded. What is the content of that record? Whether it is audio or video, whatever it may be. I am taking a photo of your classroom. Day number one class, one photo. Day number two, one photo. Day number three, one photo. In this way, 45 days, 45 pics I have taken. End of the day, the candidate who I want to maintain attendance based on the images. What about images, audios, videos? All this content is structured or unstructured? Purely unstructured. If it is structured means every record has to follow same pattern. But in the images, understand, is image is a structured content or unstructured content? Purely unstructured. Video, audio, even raw text, whatever the thing I am typing on the notepad text, the raw text, your Facebook review. Suppose recent movie is KGF. For KGF, the user number one is giving review, user number two is giving review. But first user review, second user review, the pattern wise difference will be there or not? Understand the points. All these things comes under raw text. All these things unstructured data. If you talk one enterprise, only 20 to 25% of data is structured data, sir. Remaining percentage of data, like 75% of data is, majority is unstructured. Still, semi-structured data is available. That means with the RDBMS regular systems, traditional warehouse systems, you have good solution only for structured data, but not for unstructured and semi-structured. But most of useful information is available with structured and unstructured also. Structured is important, at the same time unstructured is also very important. It will give you a good insight which is required to your business. Okay, so this data lake should support storage and process of unstructured, semi-structured, and also structured. So all these things are supported by this. Please list me examples of unstructured: images, audios, videos, and also raw text. So image classifications, your face detection, such kind of applications comes under this unstructured image-based analytics. Of course, machine learning people, deep learning people use to build their models to recognize our face, to recognize our expression, like that. Being a data engineer, you need to prepare the data as data scientist is expecting. This is one of the role of a data engineer. But not only this role, a lot of other roles will be there. Step by step, you will be understanding about that. And semi-structured data. Whenever you call, nowadays, different application, the requirement is different applications or different business vendors need to be integrated in the form of applications. One application is sending request to other application is sending response in the format of JSON or XML. All old applications are sending their responses in XML format. Latest applications for the past 10 years, most of applications are sending their responses in JSON format. That means the majority of your content also can be in XML and also in JSON. Your data lake is supporting all these varieties of data storage and also data process. And there is another benefit with the data lake. The third important benefit is all formats of data. It supports all formats of data. Especially in general, in our Windows system point of view, what are the formats? Generally, we are using different file formats. One is a .txt file, CSV file, okay, zip, or if it is Linux systems, you are using a .tar or gzip, gunzip, such kind of special formats you are using. But all these, remember, all these formats used only for small volumes of data only. Whenever you want to compress a petabyte of data, your zips or gunzips won't work out, sir. Understand the point, sir? So that's why for big volumes of data, especially, there are many formats. Of course, data lake supports traditional formats like zip, tar, gzips, even it supports CSV files, Excel files. All these are the different formats. All these are for small volumes, and also data lake should support a big volume formats. The big volume, especially in big data, special formats will be there, like RC format, row columnar format, ORC format. You don't worry about all these new words, but useful, you will be understanding in coming classes. When to use what type of format, you will be getting grip over that. RC, ORC, and also Parquet. Most popular is Parquet nowadays. So for simply, what is the need of these special formats? A simple example I'm going to explain. Suppose Microsoft is charging for 1 terabyte of storage, 300 rupees, sir. 300 rupees change. Let's assume 300 rupees it is charging. Your organization has 100 terabyte of data. What is the monthly bill for you? What is the monthly bill for you? If it charges 300 rupees per terabyte, your organization has 100 terabyte of data. The monthly bill is definitely 30,000 rupees. Got it? Now your client is asking you to save this bill. You are a data engineer. He doesn't want to lose the data. Compromising two ways, sir. Instead of storing 100 terabyte, I will keep only 20 terabyte. That is called compromise. But no compromise required here. I want to store this data into the cloud, but my bill should not be high. My bill should not be high. It should be very less. As max as possible, I should try to decrease the bill. So here two ways. One thing, sir. Today I'm storing means next onwards I will be processing, right? Think that in Microsoft you have additional bills for the storage, additional bill for the processing also. For storage 30,000 is the bill. For processing, think that 90,000 is the bill. For our regular processes. Think that is going to take 10 hours time to process the data. For 10 hours they are charging 90,000 rupees. Just assume like this. Now issue is with me, I need to reduce the bill. Simply what I do is, I convert this file, normal file, into parquet format. The parquet, basically it is offering me two benefits. One is 75% data compression without loss of data. 75% of data compression if I convert my file into parquet. And second benefit, very faster in process. Generally, the industry estimated the industry feedback 10 times faster than regular raw format files. 10 times faster than traditional files, because the internal data storage structure is very different. There is a special format called columnar store format with indexing. Columnar store format with indexing. Okay, that format is 10 times faster than traditional files. Now, because of this, if I could able to convert this 100 terabyte into parquet, what is my data storage, sir? 1 terabyte is going to 75% discount in the storage, 75% storage space saved. Now your 100 terabyte will become what? 25 terabyte, right? Understood or not? For 1 terabyte, 30,000 is 300 is my fees. For 25 terabyte, what is my fees? 7,500. Understood? 7,500 is my fee now, my bill. My bill saved or not? Storage space saved means definitely bill is saved. And also for the processing, previously with the traditional file, with the traditional format, 10 hours is the processing time. Now the 10 hours, because parquet is 10 times faster, the 10 hours became 1 hour processing or not? That means my 90,000 bill will become 9,000 or not? Understood? My bill saved or not? This is just one technique to optimize your pricing. In this way, many techniques are there. Understood this point, sir? This is just one of, that's why the formats are also important. But you should have the clarity when to use RC format, when I should use ORC, when I should use parquet format. All this clarity you should have, being a data engineer. So in the day number one, you cannot get that idea. Okay, as journey goes with this data lakes and ADF, you will be getting that idea. Okay, so now till then, just we are talking about our second Azure Data Engineer product, that is Azure Data Lake. We have three benefits: unlimited data storage, all varieties of data storage, and all formats of data storage, especially suitable for big volumes of data. Because your client is coming to cloud because of his big volume of data. Because maintaining that much of big volume of data in the on-premise systems is very tough for your client. That's why he is migrating to the cloud. Definitely need to work with big volumes. That's why special formats are required for you. Understood? So now come back to your picture. I have Azure Data Lake. But what is that Azure Data Lake? Simply is a cloud DFS. That means finally you are going to store the data in the format of files only, right? But it cannot give you the behavior of a database. It cannot behave like a database. Sir, I can store my data into a file. I can store my data into a database table. What is the difference between storing data into a file, storing data into a table? Suppose all employees data I can keep into employee file. All departments data I can keep into departments file. Products into products file, customers into customers file. In this way I can store. But what something I'm missing? If I store my data into files, something I will be missing. What is that? If data is in file, file to file, we cannot set up relationship. Understood, sir? If data is in file, I repeat the statement. If data is in file, I cannot set up relationship between files. Suppose you take employee data. I am taking some related data, sir. I have different files. All of you try to observe this. All my employees in employee.txt. All my departments are in departmental.txt. All employees attendance, that is maintained in attendance.txt. All the salary transactions are of my employees are in salaries.txt. Sir, all these files are interrelated or not? Logically, there is a relationship, right? But if the data is in file, you cannot set up a relationship between them. But instead of doing that, if I go with RDBMS, in the RDBMS, your first word is R. R means relation. Relation between objects, data objects. Suppose I have employee table. All these are tables, departmental tables, salaries tables, and attendance tables. Using primary key and foreign key constraints, I can set up relationship between tables. Understood? Suppose this is under one schema, if it is employee schema. For example, for my sales related operations, I have a sales schema. In that, sales transactions are there. Sales transactions by whom? By customers. Customers are doing transactions for what? To purchase the products. Before purchasing, before transaction happened, by the customer, orders will be generated. Customer order or dealer order. Now you tell me. Order is about, I'm going to book an order. Order is about what? Order is about what? A product. But order booked by whom? A customer. Understand the point, sir? Once the order is confirmed, that is converted as a transaction. Finally, all these components are interrelated or not? Logically interrelated, but physically we can set up a relationship between them by using primary key and foreign key. That means in the data warehouse also I need a system, especially for my structured data. Especially for my structured data, I need data warehouse as RDBMS. I need one RDBMS in the place of our data warehouse. Similar to Teradata, similar to Netizen. I am expecting some database. The database should be RDBMS to set up the relation. That too, that should be in the cloud. Understand? What I am expecting is, I am expecting one new system that is cloud-based RDBMS. RDBMS. That too used for data warehouse. That too with the parallel process. The parallel processing capability is similar to Teradata, similar to Netizen. I need that kind of system in the data warehouse. That is your third product, which is Azure Synapse. Azure Synapse Analytics. The full service is Azure Synapse Analytics. Within this Azure Synapse Analytics, there is a database called Azure Synapse SQL Pool DB. The short name is Synapse DB. Generally, we call it as Synapse DB, but Microsoft call it as Synapse SQL Pool DB. What is that SQL Pool DB? Simply is a data warehouse in cloud of Azure. Understand? Now I have two things in the data warehouse side. I have two things. Come back to your picture. Azure Synapse. This is cloud RDBMS used for data warehouse. Next onwards, no need to use these kind of systems. No need to use Hadoop, no need to use RDBMS like Teradata, Netizen, Vertica, and all these things. Got it? Look at Azure Data Lake and Azure Synapse. Both are in the place of warehouse only. Both are in the place of warehouse only. But when to use what? Synapse or DBMS. Can I keep all my structured data into Synapse? I can. If data is structured directly, I can direct that into Synapse. But I have a lot of content of unstructured and semi-structured. I can keep into data. Understood this point, sir? Now we know 3 products. The 4th important product is Azure Data Factory. Left side OLTP systems you have, right side data warehouse system you have. All user transactions are happening at OLTP systems. Today I am doing a transaction. Today I am doing a transaction means by tonight or tomorrow morning, that is history, right? Of course, 1 minute back transaction, now in the current moment, that is a history. But how to bring that transaction into my OLTP system? All transactions are kept at OLTP. I have warehouse systems with names Synapse or Data Lake. How to bring my OLTP systems into these warehouse systems? There should be some special processes. ETL. By using ETL tools. The popular ETL tools, Informatica, Data Stage, even Pentaho, Talent. In this way, many popular ETL tools are there, but those are on-premise ETL tools. I need one ETL on the cloud, that is ADF. Using ADF, you can connect with cloud databases and also non-cloud databases and also NoSQL databases. And you can extract the data and dump into Data Lake or Synapse. And then you can perform transformations. If I perform transformations, once data reached into Data Lake, parallel process will happen, so that previously some processes are taking hours time. Now in the minutes, I will get the output. So that our style is not ETL, our style is ELT, extract, first load, and then perform transformations. Again, transformed results load into again target missions. Understand? Now, small question for you, sir. Even meeting disconnected, please don't go. A small questions for you. Just in 5 minutes, the meeting is going to like terminated. Please rejoin into the same meeting. Come on, sir. I have a product Azure SQL. What is this simply? Azure SQL. Today only we discussed. Our first product is Azure SQL, sir. What is that? Let me check the chart. But Synapse, Mr. Bala, your answer is correct. Your answer is correct. Is a cloud RDBMS, but Synapse is also cloud RDBMS. Azure SQL is cloud RDBMS of Azure, okay, but used only for OLTP, remember. Used only for OLTP. It cannot capture unlimited of volumes. Understand the point, sir? Mainly that is especially the data modeling in the Azure SQL, the architecture of the Azure SQL is designed in the way of to capture user transactions and to respond to the user operations, but not for analytics operations, not for the batch processes. Understand? For that you have one more RDBMS, that is Azure Synapse. Azure Synapse SQL Pool DB. Simply you can short name. You can give a short name. Yes, Synapse DB. That is also RDBMS in the cloud, but used for data warehouse. That is for data warehouse. Mr. Raghavendra, that is your answer. You asked the difference between Synapse and Azure SQL. Both are RDBMS, but Azure SQL architecture is designed especially for OLTP. Okay, Synapse architecture is designed for data warehouse, which supports parallel process. Understood? Come on, I have another question. What is Azure Data Lake? Data Lake. Cloud distributed file system. Technical name, sir, for a layman, answer like this is a cloud storage. But for a technical man, answer like this is a cloud distributed file system. Understand the point, sir? It's a cloud distributed file system. Hadoop distributed file system. Data Lake distributed file system. Here Data Lake is on the cloud. Hadoop is on premise. You need not to worry about any infrastructure. Today you have terabyte, keep in the data lake. Tomorrow you have petabyte, keep in the data lake. Automatically, the backend clusters will be scaled up for you by the Microsoft Azure. Understand? Based on how much data volume you are storing, based on that, you will have to pay to the Microsoft. My organization is small, I have 1 terabyte, I will pay only 300. Your organization is bigger, 1 petabyte of data, you will pay accordingly. Understood? Okay. I'm coming to my actual questions. Sir, online team, you also try to respond. Now you are saying 3 areas. There is one more area, sir, visualization area. There is a department, visualization area. What are the popular visualization tools? You have Tableau. And if it is Microsoft, you have Power BI. And Cognos TM, SAP BO. In this way, many visualization tools are there in the market. Finally, these visualization tools are taking input from the warehouse, and finally, they are providing their business reports or visualized reports. Now I have a product Azure SQL. Where is the location? In which department Azure SQL? Just by seeing this picture, you can answer. I have a product Azure SQL. In which area I need to keep it? In OLTP side. In OLTP side, I cannot keep suppose if I keep my Azure SQL in warehouse side, I will be failed. Right product at right place. That is important. Come on, sir. Where is the location of Synapse? Where is the location of Synapse? Warehouse side. Data Lake. Warehouse side. Where is ADF? ADF. Online team, I am expecting from you. Offline team answered as data warehouse. Yes, sir, Bala. You correct. Your ADF is not in OLTP, not in warehouse, in between that. That is integrating OLTP systems and warehouse systems. That means that is data integration service or data ingestion service.